Hello, I'm going to talk in this video about radicals. I'm going to use this piece of paper because you know how important it is to reduce for our environment. So that's why I am reusing this piece of paper. All right. So introduction to radicals. First of all, I'm going to write an example of a radical. All right, it can be multiplied by a number, and here I can have an exponent. Okay, so the parts will be this. This is called the index. This will be a coefficient, like when we are working with polynomials, and then this is called the radicand. All right. This number, the index, must be a natural number, okay? So let's do some examples. If I am calculating square root of 81, remember that when I don't have a number here, it is like if I had a number 2, and we call it a square root. A square root of 89 will be positive or negative 9. Why? Because if I square 9, the result is 81. I square it because I'm working with an index of 2. Or if I square negative 9, I also obtain the radicand. This is why, okay? If I had this, there's no possible result, okay? Because if I choose, for example, positive 9, positive times a positive is never a negative, and a negative times a negative is never a positive. So this doesn't have a solution in the set of real numbers, okay? And if you think about it, if I have an even number here, even number, remember that even numbers are 4, 2, 4, 6, 8. And inside the radicand, it's a negative number. It won't have a solution in the set of real numbers. All right? Other thing. Now imagine with the same example. If I write this as a power using prime factors, 81 would be 3 to the power of 4, okay? So how can you solve this radical? You can divide this by the index and you obtain the result. Remember that when this is an even number, you always have two results, the positive and the negative. If you have, for example, cubic root of 27, if you write this as a power with using just prime numbers, this will be the result. If you divide, the result is 3. Here I don't have the option to have a negative number as a result, because if I multiply negative times a negative is a positive, but a positive times a negative is a negative, so I just have one solution. But with an odd number here, remember that odd numbers are 1, 3, 5, 7. I can have a negative number as a radicand, and the result will be this. Okay? So how to write a radical as a power? Write a radical as a power. It is easy because we have talked about how to solve them. So if you have something like this, I can write it as a power like this. Okay, the index, sorry, this is an N, not an M. The index always goes to the denominator, okay? So I can have many equivalent radicals. for the same number, okay? Why? Because the same way than with fractions, I can have infinite equivalent fractions, because if I might multiply numerator and denominator by the same number, or I divide numerator and denominator by the same number, we are talking about the same fraction. The same happens with the radicals. So if I have this, remember this is like a fraction, c over n. This will be an equivalent radical. I can put h could be any number, okay? Or I can divide n divided by h, and c divided by h. And I would have many equivalent radicals. If I have two different radicals, I could find radicals with the same index, all right? So for example, imagine that I have a square root of 2 and fifth root of 3. I could find equivalent radicals with the same index. So this is similar when we work with fractions, okay? So I could write that I have to find a multiple of this index and this index. In this case, the least common multiple could be 10. So if from here to here I have multiplied by 5, this one that would be the exponent, I have to multiply by 5. And here, if I have multiplied by 2, in this case I have to multiply by 2. So I found equivalent radicals, but with the same index. All right, and I'm going to end talking about extraction of factors. So if inside a radical, for example, let's say here I have an index of 5, and here I have 2 to the power of 12. I can extract some factors because this exponent is greater than the index. So I could divide 12 by 5. The result will be 2. And the remainder will be 2 as well. So I can divide 12 by 5. And the result is 2 to the power of 2 squared. All right. But I should go on dividing 2 by 5. So then I have to write this, because I still would have, because 12 equals 2 plus 2 divided by 5. So I express these powers with the same base. Here I write this because I could divide. This is the quotient. And then I should express that I still would have to divide this by this. All right? I hope it is clear. You will like working with radicals because it is entertaining, all right? Bye, see you soon.